Welcome, class. In slide 1, we entered some numbers, we entered the Fibonacci sequence, we highlighted the Fibonacci sequence, we entered some shapes, and we practiced writing, making mistakes, and making some corrections. Slide 2, we got just a little bit fancier, and we told what we think of mathematics. Math rocks, speed up a little bit. Math rules, speed up a little more. Math rewards, slow down the timeline. In Doceri, we can add photographs, we can add graphs and graphics, and in fact, the sky is the limit. Here's a set of axes and a graph. We created the axes using the line tool and constrain mode so that our axes were at right angles to each other and that they were horizontal and vertical. The axes could be any color we wanted, as could the freehand that we've laid over the axes. Here we've drawn an example of an exponential function. It's an exponential function because the independent variable is in the exponent. Now, is this actually a function? Calling it a function doesn't make it so. There are certain conditions that the graph has to satisfy if it's the graph of a function. And you may remember the vertical line test, which just says that if I draw a vertical line anywhere on this graph, it can cut the function at most once. And that vertical line I've just drawn cuts it exactly once. This vertical line cuts exactly once. Every vertical line that I would draw would cut this function at most once, which means that it really is the graph of a function. We can ask other questions about this graph. Does this function, the graph of this function, does it have an inverse? And if so, how would we know that? And there is another test that we often use called the horizontal line test. And the horizontal line test tells me that the function will have the property of being a one-to-one function if every horizontal line that I can draw in the plane will cut the function at most once. The yellow horizontal line cuts where I drew the yellow circle. The second horizontal line I draw cuts where I drew the second circle. So the horizontal lines that we've just looked at cut the graph at most once. But what if I drew a line down here where the y values are negative? That will never cut the graph of the function. Does that contradict its one-to-oneness? And the answer, of course, is no, it doesn't. The rule is it can cut at most once, but it doesn't have to cut at all. Well, if horizontal lines cut the graph of the function at most once, we say the graph is the graph of a one-to-one function, and it will have an inverse. Now, how do we know that? We've already answered the question. We know that because this graphic passed the horizontal line test. In this last graph, I'm just putting an end to our recording. Thank you. Study your math. Be kind to each other. And if you ask me, I'll tell you about moving around text in the timeline. Thank you, and have a good day.